I'm from the University of Miami, the College of Engineering, the Department of Biomedical Engineering, and this is part of the BME 440 Lab Tutorial Series, and today I will be introducing you to the oscilloscope. This is the oscilloscope. The oscilloscope is like a DMM, except for alternating voltage. If you're generating any sort of voltage using the function generator, pictured over here, you will need to use the oscilloscope because the oscilloscope can better monitor changes in voltage, as can be seen by the sine wave currently being generated. So today we will be demonstrating the function of the oscilloscope. Now we will be doing this on an operational amplifier in an inverting configuration. This here is a resistor with a resistance of 2.7 kilo ohm, and this resistor has a resistance of 27 kilo ohm, giving our expected gain a value of -10. Now, in order to test our oscilloscope, we will be using a function generator, generating a function at 500 Hertz, a sinusoidal function at 500 Hertz, and an amplitude of 1 volt. So we will attach the ground to the ground and the input to the input. Now, in order to use the oscilloscope, we'll need to use the oscilloscope probes, pictured here. One has a yellow marking on it, indicating that it is channel 1 and will give an output of a yellow line. And this one has a green line on it, indicating it is channel 2 and will give an output of a green line. So we are going to attach channel 1 to our input in order to monitor our input function, and we will attach the ground to our ground, and then we will be using channel 2 in order to monitor the output, which is right here, and we need to attach our ground to the ground as well. As we can see, our function is shown up on the oscilloscope, however it is not properly scaled. So in order to fix this problem, we can simply push the auto scale button and it will resize our functions to look nicer. So we've auto scaled it, and now we can move the functions to be superimposed on top of each other for easier comparison. Now it's important to note the scale on each function, which is noted on the bottom left side of the screen. As you can see, for channel 1, which is the yellow line, the scale is 1 volt per division, and for channel 2, which is the green line, the scale is 5 volts per division. So if we look at the function, we see that the amplitude of the green line is 2 divisions, meaning that the output is 10 volts, or has a 10 volt amplitude, and the input has an amplitude of 1 volt because its scale is 1 volt per division. Now, our function generator is currently generating a function at 500 Hertz. We can change that on the function generator, and as you can see, we get a response on the oscilloscope in which our function gets stretched out or gets smaller. Now, if we get in a situation like this where we can't see our function anymore, we can simply auto scale it again. And our oscilloscope has rescaled. Almost lost that function there. And our oscilloscope has rescaled the horizontal divisions to be 20 milliseconds per division, as opposed to our previous divisions that were 500 microseconds per division, allowing us to see lower frequency ranges. Additionally, another thing that the oscilloscope can do is allow us to move horizontally across our function using the knob up here. As you can see, we can just see a wider range of our function by using this knob. And we can also take certain measurements. I'm going to put us back into 500 Hertz for this part. So using the measure button, we can find stuff such as the peak-to-peak voltage, which you can see it gives us the peak-to-peak voltage of 20 volts for our channel 2 output, which is exactly what we would expect, seeing as the amplitude is 10 volts due to our operational amplifier having a gain of 10. Other things that can be found are the disappears on you, are the Vmax, which is 10 volts, which is what we would expect, as well as Vmin. Everything keeps popping up down here so that it's easy to record. If instead of going measurement by measurement we want to get a lot of data about our function, we can simply go to Measure, Display All, and this will give us all the measurements on the voltage that the oscilloscope has taken, including Vmax, Vmin, and Vpeak to peak. So the current waveform we are using is a sine function. However, a function generator can generate all sorts of functions, and the oscilloscope will show all of those. For example, if we switch to a square waveform, the oscilloscope shows a square waveform.